Okay, this is the second lesson on the law of sines. We had learned in the previous lesson about how the law of sines can be used to help us solve for triangles that are not right triangles. Okay, specifically, the law of sines is most beneficial when the information that you're given are two angles and then a side that's not included in between the two angles, or if you're given two sides and then an angle not included in between those two sides. Okay, remember, this is how the setup is. It's the sine of your angle divided by the opposite side. You can pick any two of these fractions to set equal to each other, and then we solve that proportion. It is important to note that when you're doing this, your calculator must be in degree mode. So I would check that right now. Go ahead and check the mode button on your calculator. You need to be in degree mode, not in radian mode. Okay, this lesson can be a little bit tricky, so it's going to be important here today that you're taking really good notes. Law of sines can get a little confusing, particularly on problems when the information that you're given are two sides and an angle not included in between the two sides. Okay, now we know from geometry that what an isosceles triangle is it's a triangle with at least two equal sides. And you can see some of these are pictured over here. These little tick marks are showing you the two sides that are equal to each other. And what we want to remember about isosceles triangles is that the angles that are opposite the equal sides, okay, the angles that are opposite the equal sides, those angles are always equal to each other. So I'm going to demonstrate this for you here in these two pictures. Okay, we're talking about these angles right here. They're opposite those two equal sides. Those angles would then be equal to one another. Okay, same thing over here in this picture. These angles would be equal to each other. And that's going to be something important for us to remember as we're working through this special case in law of sines when you're given two sides and an angle not included in between the two sides. Okay, now, for starters, when you are given, say, two angles and a side not included in between the two angles, okay, that would be angle, angle, side, there is actually only one possible triangle that could be constructed with that given information. Okay, so that's pretty simple. However, if you're given two sides and an angle not included in between those two sides, okay, we refer to that as SSA. An easy way to kind of remember this is if you were to reorder those letters, we could be spelling, a slightly inappropriate word here. This is the special situation where something weird can happen with your triangles, okay? So only in this circumstance, when you're given two sides and an angle not included between those two sides, you have actually three possibilities that could take place depending on the measurements of the side and the measurement of the angle. There could be no triangles at all that could be constructed with that given information. There could be only one triangle that could be made with that given information, or it's possible that there are two triangles that could be made with the given side measurements and the given angle measurement that you're given here. Okay, so I want to look at each of these three scenarios, and this is where this can get a little bit tricky here. So I want to start over here on this left-hand side. I'm going to just kind of highlight to make this a little bit more obvious. Remember, this situation is side-side angle. So what that means is the problem is going to give you the length of one side, the length of another side, and then the problem is going to give you the measurement of an angle. Notice the angle that they gave you was not the angle included in between the two sides. That's why we call this side-side angle. Okay? It's possible that the measurements that you are given for the two sides and this non-included angle, if you were to actually try to construct and measure out those three pieces of information, that you would not really be able to even form a triangle. Okay, I want you to think about this here. If I were to take, say, this side down here and make it connect from A to where side A stops, if I were to actually connect that, look at what we've changed. we have changed what the measurement of angle A is. Okay, angle A is supposed to be something that was provided to us in the problem, that's fixed, that we can't actually change. So depending on the problem and the numbers they give you, one option is it is actually not possible to make that triangle. Now, how would you know that? Well, we're going to go through an actual example of this, but one indication that you could have 0 possible triangles is if the angle that you're given, that given angle would have to be acute, okay? And when you go about solving the triangle, and we'll see this in an example, ultimately you end up getting an error as you begin to solve the triangle. If you get an error, that means that you had 0 triangles possible. You could not make a triangle with that given information. Okay, now the other option, and this is probably the most complicated one, is it is possible that given the information that there are actually 2 triangles that could be constructed with that information. So let's say that you're given the length of side A, you're also given a length for side B, and you're given what that non-included angle is, angle A right here. Okay. Now, it's possible that one triangle would be to kind of close off this side right here. And so you could see one triangle would somewhat look like this, okay? But it's also possible if you picture this side A, like you could swing it back and forth. The length is going to stay the same. If you take side A, like there's a hinge right here, and you swing side A down, and it comes back up over here on this side, so that now I haven't changed the length of side A, but now this triangle kind of looks like this. Okay, so I have angle A, side B, side A, still the same 3 measurements that we were given in the problem. Okay, this could be a totally separate second triangle with still the same values. Side A is still the same. Okay, now here's how you know if you're going to have 2 triangles. Okay, once again, the given angle that you start out with in the problem has to be acute. So that's the same situation as when you have no triangles possible. Okay, but here's what you're going to do. You're going to find your first angle, and once you have the first angle, you're going to subtract it from 180 degrees to reveal the second angle in your triangle for angle B. Okay, now the reason that we're subtracting it from 180 is because here's angle B in my first triangle. Okay, that would be this angle right here. If I swing side A over here, remember we said that all of these isosceles triangles, and this would be an isosceles triangle kind of right inside here, the angles opposite those are always equal to each other. So whatever this initial angle B is, what I'm really after is what this angle over here on this side would be. Okay, so angle B, same as this angle here. I want this side over here, so I take 180 and I subtract my angle B from that. That gives me what the other angle B would be in, say, my second triangle. I know this sounds super confusing. Hopefully this will make sense as we kind of look at another example. But when you find that first angle B, if you get an error, then you know, oh, there's no triangles possible. If you actually get an angle measurement, then you're going to subtract it from 180 to get what your angle B is in the second triangle as well. Okay. The other option is that there's just one triangle possible. Okay, and this is the situation where the angle that you're given, okay, the given angle is actually an obtuse angle. Okay, and so when you get that first angle and you go ahead and try to subtract it from 180 to find your second angle measurement for angle B, you discover that that second angle measurement for angle B, when you combine it with the one original angle you were given, you have already exceeded 180 degrees in your triangle, so there's no way that a second triangle is actually possible. Okay, let's look at this with some examples so that we can try to make sense of what we were just talking about here. Okay, now what you're going to do is the question is wanting you to solve the following triangles. And so when we solve a triangle, it means that we find all the missing angles, all the missing sides. I've set these up in such a way that we're assuming there might be 2 triangles possible, but we might not fill in all these blanks if we discover that there's no triangles possible or just 1 triangle possible. So here's what you're going to do at the beginning. You're simply going to draw a triangle. Now let's look at the angle that they give us. Okay, they're giving us angle R is 105 degrees. So I'm going to go ahead and at least try to draw it in such a way that it looks like angle R is obtuse. Okay, so 105 degrees we'll say there. Okay, side R they give us is 9, and then side S is 6. Now this is triangle RST, so you can put the S and the T, either one of the 2 vertices you want. Side S is 6. I'm going to put that over here. Okay, now here is my side angle that I'm given. Okay, we want to figure out, are there no triangles possible, 1 or 2 possible? Okay, so we're going to use law of sines. Okay, remember how law of sines work. We always want to start with a pairing where we already know an angle and a side opposite that angle. So we're going to do sine of 105 over 9 equals, looks like I'm going to find angle S first. Sine of S, I'm wanting to kind of pair that up with the 6 that we know there. Okay, put that over 6. Okay, now what we're going to do is we're just going to cross multiply. Okay, so I've got 9 sine S equals 6 sine 105, and this is why we want to make sure that we are in degree mode here. We're going to divide by 9, and then if you recall, to solve for a missing angle, the only way to break this trig function apart is to now do the inverse sine. That cancels off sine, leaves me with angle S. On the right side, I also have to do the inverse sine. So here's what you're going to type on your calculator. Inverse sine, then in parentheses, 6 sine. Now when you hit the 105, make sure you close up the parentheses on the other side of the 105, divide by 9. This is going to give you that angle S is, if we round it to the nearest degree, 40 degrees. Okay, so I'm going to go ahead and put 40 degrees on my blank here for angle S. I also want you to add that to the picture, 40 degrees. All right, well, I've got 2 of my angles here, so to get angle T, I should just be able to add up 105 and 40 and subtract that off of 180. That's going to give me angle T is 35 degrees. I'm going to go ahead and add that to my picture here. Okay? All right. So, we need to find angle T here. Okay. Oh, I'm sorry. I probably should have mentioned that before I found angle T, as soon as you get this very first angle that you find, just to make sure that there's not also a second triangle that you could make, what you immediately need to do is take 180 minus that angle. If there is a second triangle, angle S in the second triangle would be 140 degrees. Now let's think through that. If angle S in a second triangle is 140, but we're already given that angle R is 105, there's no way, we've already exceeded the 180 degrees that could exist in a triangle. So that's how we know that there's no way that there are 2 possible triangles for this. I'm going to circle up here. There's only 1 possible triangle. Okay, and now I'm going to find side T by setting up the original fraction, sine of 105 over 9, and I'm going to set that equal to sine of 35 degrees, that's angle T, over side T. Okay, I'm going to go ahead and cross multiply. Okay, and then we divide by sine of 105. We type this right here into the calculator, and we get as our answer for side T to be 5.34. Okay, as you find these, always add them onto the picture. I'm going to go ahead and cross off this other line because we said there was not a second triangle. Okay, let's try another one here. Okay, this is triangle ABC. Let's look at the one angle we're given. This is an acute angle. Okay, this is an acute angle here. So with this acute angle, these don't have to be drawn to scale here at all. Okay, I'm just going to label my vertices ABC. We're going to call angle A 54 degrees. Okay, let me make sure this is clear here. That was 54. 54 degrees. Side A is 6, side B is 8. Okay, you're just going to start the only way you can start, which is setting up one law of sines ratio. Sine of 54 over 6. My only option is to find angle B first. Sine of B over 8. Okay, I'm going to go ahead and cross multiply. I'm going to divide by 6, and then because I'm solving for an angle, I'm doing inverse sine of both sides. Okay, I'm typing into my calculator inverse sine of 8 sine 54 divided by 6. This gives me the measurement of angle B to be okay. Now I'd like for you to type this in. Please try typing this right here into your calculator. You should see an error message. Okay, if it's giving you an error message, this is the situation where technically if we were to really measure these things out, this is not possible to make a triangle with those measurements. So I'm simply going to write down no solution, and then I'm going to circle up here that there were 0 triangles possible. Okay, no triangles were possible for that. So anytime you get an error message as that very initial process of solving that initial law of sines, that's when there's no triangle. Okay, let's go ahead and try example C. Okay, here the angle that we're given is angle A, 35 degrees. So I'm going to go ahead and draw a triangle A, B, C. We're going to label 35 degrees here for angle A. Side A is 17, side B is 20. Okay, I'm going to set up my initial law of sines. Sine of 35 over 17 equals sine of B over 20. Okay, we're going to cross multiply here. Oops. Okay, and then what I'm going to do right now is I'm just going to do the inverse sine of both sides. Okay, so what you're typing into your calculator is the inverse sine of 20 sine 35 over 17. This is going to give you the measurement of angle B to be, if we round it to the nearest degree, 42 degrees. So I didn't get an error, so I know that there's not 0 triangles. There is either only 1 triangle or there are 2. Okay, before you go on and solve any other missing pieces to this triangle, to determine whether there's only 1 or 2, what you need to do next is you need to take this very first angle that you found, subtract it off of 180, okay? Subtract it off of 180. The angle measurement you get here would be what the measurement of angle B is if there is a second triangle that exists. Now I want you to think about this. I'm going to go ahead and just draw a second triangle. Again, this is totally not going to be to scale at all. Okay, I'm going to put the given information from the problem. And what we're saying is if a second triangle exists, then the measurement of angle B in that triangle would be 138. Now what we want to see is that possible? If we take the given angle 35 plus 138, does that already exceed the 180 degrees that can exist in a triangle? And actually, these two angles add up to be 173, which means there is an extra 7 degrees left for this other angle C. So this is proof that there actually are 2 possible triangles. Now, this triangle wouldn't actually look like this. I would need to draw it so it looked obtuse, but that's fine. So technically, angle B in a second triangle would be 138, and that extra 7 degrees is what I would fill in for angle C in that second triangle. Okay, now I'm going to go back to the first triangle. We're going to solve all the other missing pieces in the first triangle. Let's go ahead and add up the 2 angles, 35 and 42. Okay, if we add 35 and 42 up, we get 77. We subtract 77 off of 180. That leaves for angle C 103 degrees. I'm going to add that on the line and on the picture. Okay, one last thing we have to solve in this triangle, and that would be side C. Okay, so we're going to set up another proportion here. We're going to use the initial givens here, sine of 35 over 17, and we're going to set that equal to sine of 103 over side C. Okay, again, we're going to cross multiply. Divide by sine of 35. This is going to give you side C to roughly be 28.88 units. So I'm going to add that on the blank and on the picture. Okay, now I have to come back to my second triangle. I also have to find side C in my second triangle. So I'm going to do sine of 35 over 17. Okay, I'm going to use that, and I'm going to set it equal to sine of 7 degrees over side C. Okay, these are the longest problems when there are two triangles because you have kind of twice the amount of work to do. Okay, I think the trick with these problems is when you find your first angle, if your first angle is an error message, you're done. The answer is no solution, and you are simply saying there are no triangles possible. Okay. If you actually get an answer, you immediately take that answer for that angle, you subtract it off of 180 like we did here, and if that answer combined with the given angle doesn't surpass 180 degrees, then you have a second triangle. You need to immediately draw a second triangle, put all the given labels on your picture, plus what that new angle, in this case B, would be, and then you go about solving both triangles. I got angle C, or I'm sorry, side C in that second triangle to be 3.61. Okay, we're going to try one last one here. Okay, here we are given triangle MNP. We're given that angle N is 32 degrees, side N is 7, side P is 4. Okay, I'm going to set up my initial fraction here, my proportion. Sine of 32 over 7 equals sine of P over 4. Okay, we're cross multiplying, dividing by 7. When you solve for an angle, we're doing the inverse here. Okay, this is a 4 right here. Okay, you're going to type in inverse sine of 4 sine 32 divided by 7. This is going to give you the measurement of angle P to be 18 degrees. Okay, so I'm going to immediately put that on the blank, put that on the picture, and before I do anything else, off to the side, I'm doing 180 minus 18. That gives me 162 degrees. Okay, what that's saying is, if a second triangle MNP exists, and I put the same given information on it, that angle P in that triangle would be 162 degrees. Now, I don't think that's possible because 162 plus 32, I've gone way over 180 already. That would be 194. So it is not possible for me to have a second triangle for this. There's only one triangle possible. I don't think I circled in the previous problem. There were two triangles possible there. So I'm going to go ahead and cross off right here that second blank. Okay, we can go ahead and calculate what angle M would be. We're going to add together 32 and 18. Those are our two angles. Okay, that's 50. So if we subtract 50 off of 180, that leaves angle M has to be 130. And then we just finish this with one last ratio. Sine of 32 over 7 equals sine of 130 over M. Sorry, I was touching the side of the screen here and it wouldn't let me write that 0 right there for 130. Okay, we're going to divide by sine of 32. So you're typing in 7 sine of 130 divided by sine of 32. This gives you side M to be 10.12. Okay, when you're done with these, your pictures should be fully completed, all sides, all angles labeled, and your blanks should all be filled in here. Okay, you can see that there is a worksheet here for you to go ahead and try. That is worksheet 12.4B.